Everyone, this is Dr. Bilal Zafar, and the topic of our today's discussion is forest plot. Now, what is forest plot? In this video, we will discuss what is forest plot, and we will understand some of the basic concepts related to forest plot. The first question is why do we need forest plot, and what is forest plot? Forest plot is basically a graphical representation of the systematic review and meta-analysis. What are systematic review and meta-analysis? They are basically the secondary researches in which we take already published studies, preferably randomized controlled trial, and we see the combined result, the combined outcome of all these published studies. If you see this graph, it seems very confusing, but in this video, I would teach you how to decode this forest plot. Okay. For that, first we'll have to know what is anatomy of forest plot. This is a very great picture which tells you about the anatomy of forest plot. If you can see that we have two axes, we have a y-axis, x-axis, and a y-axis. Okay. On x-axis, we have odds ratio here. We could have anything like odds ratio, OR, absolute risk reduction, ARR, relative risk reduction, RRR, and relative risk or risk ratio, RR. Okay, so on x-axis, we would have these values, and on y-axis, we have all the published studies, preferably, again, I'm saying preferably RCTs on the y-axis. What are these squares? These squares represents the size of these squares represent the weight of the study. Okay, what does it mean by weight of the study? Weight of the study means the number of samples included in the study. In the forest plot, we would have two different sides, the left side and the right side. If you remember, the RCTs compare two groups, one with the new intervention and one with the standard intervention, the old intervention, which we call control group. Okay, so what is the purpose of this systematic review and meta-analysis? We see the combined result that are these studies in the favor of new treatment, like on the favorable side, and on the or on the right side, which is in the favor of control group, in the favor of standard old treatment. The size of these boxes, I have told you that this size represents the weight of the study, and the position of these squares is very important. The position of these squares, if they are on the left side, on the favorable side, that means these studies individually represents the new, it represents that they are favoring the new treatment. And if they are on the right side, they are favoring the old standard treatment, that means the control group. This diamond lozenge represents the collective outcome of all these studies. As you can see that the majority of the studies lie here on the left side, which is favoring the interventional group, the new intervention. That is why the diamond lozenge also lies on the left side. Okay, so the side is very important. Now coming back to the line of no effect. This, I told you that this vertical line represents the odds ratio, ARR, RR, anything. It could be anything. For now, here, just remember that this line represents the odds ratio. Okay. And this line is known as line of no effect. What does it mean by line of no effect? It means that any study that is touching the line of no effect has an insignificant result. Okay. It is not statistically significant. What does it mean by touching this horizontal line? If this horizontal line is touching the line of no effect, that means this study is not statistically significant. Now the question arises, what are these horizontal lines? These horizontal lines represents the confidence interval. And what is confidence interval? It is basically the range in between which the true effect lies. So, for example, as you can see that for this study, the confidence interval is much smaller. This whole line from here to here represents the confidence interval. If you can see, and if you compare these two studies, the confidence interval line is much wider as compared to this study. Remember, the shorter these horizontal line, the more precise that study is. Okay, so these horizontal lines represents the confidence interval. Now, as I previously said, that we should focus on these horizontal line, like are these lines crossing the line of no effect? Okay, for first study, for second study, yes, they are crossing the line of no effect. For third study, they are not. they are not crossing the line of no effect, and fourth study, they are crossing the line of no effect. That means among these four studies, only this study is statistically significant. And that's how you would, analyze that are these studies significant, statistically significant or not, by just seeing at the graph. But for example, if you don't have the graph, you just have the studies and their confidence interval levels, then can you analyze that these studies are statistically significant or not? Yes, you can. Remember, I told you that this is the line of no effect, and here the variable we have is odds ratio. If you just go back, we have discussed this thing in our previous videos, that what are the points of no difference for different variables. These are different things which we usually use on our meta-analysis, as I previously mentioned, the odds ratio, ARR, RR, RRR, and NNT. You should know the points of no difference for all of these values. For example, in this forest plot, we had odds ratio. So you should know that the point of no difference is for odds ratio is 1. This means that any value which is crossing, which is either 1 or less than 1, that is statistically insignificant. Obviously, you can see that 1, 2, and 4, these studies are statistically not significant because their confidence interval are crossing the line of no effect. But how would you analyze or interpret it? By the values and not by looking at the graph. Let me tell you. Remember, the point of no difference for odds ratio is 1, and that is why this is called line of no effect, because it lies at 1. Now, if you can see this picture, here we have the example of risk ratio. I have cropped this picture from this forest plot. Okay, so this part, only this part. Here you can see that we also have graph, but let's suppose we don't have a graph and we only have these values. Okay, now what is the variable here? You'll have to see what is the variable mentioned here. The variable mentioned here is risk ratio. Okay, the variable mentioned here is risk ratio. Now see the values. We usually have 3 values, 1, 2, and 3. Now remember, what is the point of no difference for the risk ratio or relative risk? It is 1. You will have to see all of these 3 values. Are these greater than 1? If they are greater than 1, not just 1, not less than 1, but greater than 1. If they are greater than 1, that means your study is significant. Let's see for the first study. Is it greater than 1? No. Is it greater than 1? No. And is it greater than 1? Yes. But as I told you, that for a study to be a statistically significant, all of these 3 values should be greater than 1. And that is why if you just go back to the graph and see, this value is less than 1, this value is less than 1, and this value is greater than 1. We should have all these 3 values greater than 1, and that is why this study is crossing the line of no effect. Okay, again, this line of no effect lies at the point of no difference for that variable which we have taken, like risk ratio. If you see this study, it is less than 1, greater than 1. 2 values less than 1, the line of the confidence interval is crossing the line of no effect. That means it is not statistically significant. And just like that, all of the studies are not statistically significant. And if you see the result here, this diamond lozenge, okay, as I told you, that this represents the collective outcome, the collective result of all the studies which we have taken in our meta-analysis or systematic review. If you see, the value of this diamond lozenge is basically this 1.02. Is it greater than 1? Because we have risk ratio here. Yes, it is greater than 1. It is 0.56. Is it greater than 1? No. Is it greater than 1? Yes. The 1 value is not greater than 1, and that is why it is not statistically significant. And this is represented by diamond lozenge, which is crossing the line of no effect. That means the collective outcome is not statistically significant. Okay. Here we don't have this the values, so we cannot tell by the values. But as you can see in the graph, the diamond lozenge is clearly on this side. That means that the value for this diamond lozenge, the value of this confidence interval would be, if we have taken the odds ratio as a variable, it would be greater than 1. Okay, you should have this thing in your mind. Okay, now we have the same confidence interval. We have the same forest plot. Now let's decode it according to the things which we have discussed. Okay, so we have two groups, gamma nail and DHS. We are assuming that they in this study they are comparing the gamma nail and DHS. One of them could be a new treatment, the experimental intervention, because obviously in RCT, if it is an RCT, then we are comparing two groups. We are comparing two groups. Two groups means one is the new treatment and one is the old treatment, the standard treatment. Okay, it is represented by control, and new treatment is means experimental. Okay, so let's take first study. As I told you, that weight of the study means the number of the samples which we have in the study. As you can see, the weight of this study, the first study is 9.7. The square is very small as compared to this. What is the weight of this study? 19.9, significantly greater than this 9.7. And this square is smaller than this one. If you can see the values, the weight of this study, this is 30.6, the highest among all. And that is why this square is the largest among all the squares present. Okay. If you see the graph, then you can see that all of the confidence intervals are crossing the line of no effect. The variable we have here is risk ratio, and that is why the line of no effect lies at 1. Okay. That is why all these three values should be greater than 1. But in none of the studies, the values are greater than 1. So that is why all of these studies are individually insignificant, statistically insignificant, and obviously their collective outcome says that the collective outcome says that it is not statistically significant, and that is why, as the collective outcome is represented by diamond lozenge, it also lies at the point of no effect. Okay. Now, this is another forest plot. We have 1, 2, 3, 4, 5 studies. Okay. As I told you, that the size of the square represents the weight of the study. As you can see that this is the largest here. This means that the number of samples in this study is highest among all the studies which we have included in our RCT. Okay. We have two different sites. They have not written here, but just assume that this side favors the new intervention and this side favors the control, the old intervention, the standard intervention. Okay. The variable which we have here is ORR. OR. It is odds ratio. And if you go back, the point of no difference is for OR is 1. And that is why the line of no effect lies at 1. As you can see that the studies in the study number 1, 2, 3, they all are touching the line of no effect. And that is proven also by looking at the values. If you see, the point of no difference for odds ratio is 1. So these all three values should be greater than 1. This value is less than 1, and that is why it is crossing the line of no effect. This value is 2.1, greater than 1. It is 1, and it is 3.4. I mentioned that the value should be greater than 1, not less than 1 or not 1. Even if it is 1, that means it is not statistically significant, and that is why the value is 1, and therefore it is touching the line of no effect. Okay. Here, this value is less than 1. These both are greater than 1, and that is why it is touching the line of no effect. These two studies, their confidence interval lines are not touching the line of no effect, and that is proven by their values. As you can see, greater than 1, 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 greater than 1. Okay. And the diamond lozenge, why it is not on the line of no effect, it is on one side. That means all the three values for this collective outcome for this diamond lozenge is greater than 1, and it is also proven by this by these values 2.2, 1.9, and 2.4. They all are greater than 1. So that is how you would interpret the forest plot. Okay. The questions we usually have from the forest plot in our MRCPsych paper B is that point out which study has the largest weight. Obviously, this study has the largest weight. Which study is not, crossing the line of no effect? Obviously, these two studies are not crossing the line of no effect. Which study is the most precise? And by precision, they mean which study has the lowest confidence interval limit. As you can see here, this study has the lowest confidence interval limit, which is represented by horizontal lines. The horizontal lines of this study is much less compared to this, and this. Okay. And also they can ask that the diamond lozenge represents what? It represents the summary measure. It represents the collective outcome of all the studies which we have included. And on which side the confidence interval is present? Obviously, it is on the right side. Okay. As I previously mentioned, that we can also see the level of heterogeneity which is present. As you can see here, we have applied the two different tests for heterogeneity, chi-square test and I-square test. So it is also mentioned here in this forest plot. These are usually basically the studies, all the studies. This is one group and this is another group. All these studies compare these two groups. And here it is written the weight of the study, the number of samples. Obviously, as I told you, that here you can see the large number of people, and that is why the weight of the study is higher among all the studies. This is the confidence interval limit. And here it is a graphical representation of forest plot. So that is basically all about forest plot. If you have anything to ask, you can just ask me in the comments. Later on, we will see some other graphs because these graphs are very important from the exam point of view. Thank you so much.